Introduction. Hi everyone, and welcome to this lesson on data preparation fundamentals for machine learning. Before we dive into the technical details, I want to emphasize why data preparation is so critical. Consider this analogy. If you were building a house, you'd start by laying a solid foundation, right? You wouldn't just jump straight to interior design. Well, in machine learning, data preparation is that foundation. It's the unglamorous but absolutely essential work that enables you to build powerful, reliable models. Have you ever heard the saying, garbage in, garbage out? That's especially true in machine learning. Even the most sophisticated algorithms will struggle if they're fed low-quality data. On the flip side, even simple models can perform well with high-quality data. So, in this lesson, we're going to explore how to get your data into tip-top shape. We'll cover everything from basic cleaning to advanced feature engineering. By the end, you'll have a solid understanding of how to prepare your data for machine learning success. Let's get started. Section 1. Data Cleaning and Quality Management. We'll begin with data cleaning and quality management. This is where we roll up our sleeves and get our hands dirty, because real-world data is messy. Let's talk about some common issues you'll encounter. First, missing values. This is when you have gaps in your data. Maybe a sensor malfunctioned or a survey respondent skipped a question. Whatever the reason, missing data can throw off your models. You'll need to decide whether to remove these instances, fill in the gaps with reasonable estimates, or use more advanced imputation techniques. Now, think about this for a moment. What if you're working with a data set of customer transactions and some entries are missing the purchase amount? How would you handle that? Would you remove those rows or try to estimate the missing values based on other information? These are the kinds of decisions you'll need to make. Next, let's talk about outliers. These are data points that are way out of the ordinary. Imagine you're analyzing human heights and you see someone listed as 10 feet tall. That's probably an error, and it could skew your results. You'll need to identify these outliers and decide whether to remove them, cap them at a reasonable value, or keep them if they're valid but rare. Here's another example. Suppose you're analyzing website visit durations, and you see a session that lasted 24 hours. Is that a real user or a bot? Outliers like this can significantly impact your analysis, so it's crucial to handle them carefully. Now, what about inconsistencies? This is when your data contradicts itself. For example, you might have a country column where some entries are USA, others are United States, and others are misspelled altogether. Inconsistencies like this can confuse your models, so you'll want to standardize them. Think about this. If you're working with a global data set, and some dates are in MMDDYYYY format, while others are in DDMMYYYY, how would you ensure consistency? Standardizing these formats is key to avoiding errors down the line. Ultimately, the goal of data cleaning is to ensure your data is accurate, complete, and formatted consistently. It's like giving your data a good scrub before you start cooking with it. To recap, missing values, outliers, and inconsistencies are 3 common data quality issues. Addressing these ensures your data is accurate and reliable, and that's the foundation of any successful machine learning project. Section 2. Feature Scaling and Transformation. Next, let's discuss feature scaling and transformation. This is about molding your data into a shape that machine learning algorithms can effectively work with. Imagine you're comparing apples and oranges, literally. One feature is weight in grams, the other is color as a word. Many machine learning algorithms would struggle with this. They need numeric features on similar scales. That's where feature scaling comes in. Techniques like min-max scaling squish your data into a standard range, usually 0 to 1. Standardization, on the other hand, transforms your data to have a mean of 0 and a standard deviation of 1. These techniques put all your features on a level playing field. Here's a question to ponder. Why do you think algorithms struggle with features on different scales? Take a moment to think about that. The answer lies in how algorithms calculate distances and weights. If one feature ranges from 0 to 1 and another ranges from 0 to 10,000, the larger feature could dominate the model's calculations, even if it's not actually more important. Now, what about categorical features like color in the fruit example? We need to transform those too. One common approach is one-hot encoding. This creates new binary features for each category. So color might become is red, is green, is yellow, and so on. Let me emphasize this. The exact techniques you use will depend on your data and your chosen algorithms. But the principle is the same. Get your features into a consistent, numeric format. To recap, feature scaling ensures all your features are on a similar scale, and transformation techniques like one-hot encoding help convert categorical data into a numerical format. These steps are essential for making your data algorithm ready. Section 3. Feature engineering. Now, let's get creative with feature engineering. This is about amplifying the signal in your data. Feature engineering involves creating new features from your existing ones. The goal is to give your algorithms more to work with, to uncover hidden patterns. Let's say you're predicting housing prices. Your raw data includes a date sold feature. You might engineer new features from this, like days on market or season sold. These could reveal trends that the raw date doesn't. Here's another example. Imagine you're working on a ride-sharing app and you have a timestamp for each ride. You could create features like time of day or day of week to capture patterns in demand. Domain knowledge is gold here. If you understand the problem space, you can create features that really resonate. Maybe you know that a certain neighborhood went through a revitalization. You could create a before-after revitalization feature to capture that impact. There are also automated techniques for feature engineering, like Principal Component Analysis, PCA. These can uncover complex patterns in high-dimensional data. Now, here's a question to think about. What if you have too many features? Not all features are equally useful. Some may be redundant or even misleading. Techniques like regularization or recursive feature elimination can help you trim the fat, keeping only the most informative features. To recap, feature engineering involves creating new features, leveraging domain knowledge, and using techniques like feature selection and dimensionality reduction to refine your dataset. This step is where you can truly unlock the potential of your data. Section 4. Data pipelines. Finally, let's talk about data pipelines. This is about streamlining and automating your data preparation process. Imagine you're not just building one model, but hundreds. Or you're part of a team, and you need to ensure everyone is working with the same clean, engineered data. That's where pipelines come in. A data pipeline is a series of data processing steps. Raw data goes in one end, and model-ready data comes out the other. The steps might include cleaning, scaling, feature engineering, and more. The beauty of pipelines is reproducibility. You define the steps once, and you can execute them over and over. This is essential for validating your models and collaborating with others. Here's a thought. Can you imagine what might happen if your pipeline isn't reproducible? Let's explore that. Without reproducibility, you might get different results every time you run your model, making it impossible to debug or improve. There are many tools for building data pipelines, from simple Python scripts to full-blown ETL frameworks. The key is to design a pipeline that's modular, efficient, and easy to understand. To recap, building data pipelines involves designing reusable workflows, using the right tools, integrating pre-processing into your ML pipeline, and ensuring reproducibility. This step ties everything together and sets you up for success. Conclusion. Let's recap what we've covered. We started with data cleaning, the process of ensuring your data is accurate, complete, and consistent. Then we discussed feature scaling and transformation, techniques for getting your data into a model-friendly format. We moved on to feature engineering and selection, the art and science of creating and choosing the most informative features. Finally, we talked about data pipelines, the key to automating and streamlining your data preparation process. Data preparation may not be the flashiest part of machine learning, but it's absolutely crucial. It's the foundation upon which successful models are built. As you embark on your own machine learning projects, remember to give data preparation the attention it deserves. Invest time in understanding your data, cleaning it, shaping it, and amplifying its signal. Your models will thank you. Thanks for joining me in this lesson. In the next one, we'll dive into the different types of machine learning algorithms and when to use them. Until then, happy data prepping.